And now in this lecture we'll answer on two questions. In the first question we find out the area of square ABCD. In the second question we will find out the size of this angle theta, that is in triangle EDO. So we start with the first question. In the drawing we have square ABCD. We know that side AP equals to 5 units, side BP equals to 3 units, side PC equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all we do a construction. We extend side DC of the square by straight line. And from point P, we draw perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and the extended DC as N. The next step we will do another construction. From point B we will do perpendicular on PN. Again from point B we will do perpendicular on PN. So this angle equals to 90 degrees. And this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. In the next step we define side PM as A. Actually we define side PM as B. Side PM equals to B according to our definition, and we will define side BM as A. Here side BM equals to A according to our definition. In the next step we will implement the Pythagoras theorem on the right green triangle, triangle PBM. On the right green triangle, triangle PBM, by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on the given right triangle, triangle PBM is PB. Therefore, the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus BM squared. I'll repeat again. The right green triangle, triangle PBM, according to the Pythagoras theorem, PB squared equals to PM squared plus BM squared. According to what is given as the question, PB equals to 3, therefore PB squared is 3 squared, that is 9. and it is equal to PM squared. PM equals to B according to our definition, therefore PM squared is B squared plus BM squared. BM equals to A according to our definition, therefore BM squared will be equal to A squared. In conclusion, we found out that according to equation number 1, A squared plus B squared equals to 9. We know that all the angles inside the square are right angles. So in square ABCD we have 4 right angles. And DC is as one side of square ABCD, it is absolutely a straight line. So we extended the straight line DC by a straight line. In this way we got line segment DN. When you extend a straight line by a straight line, the result must be a straight line, therefore DN is a straight line. So I write it down, DN is a straight line. So if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees. So which angles we have in the upper side of DN at point D? We have this angle that is equal to 90 degrees plus this angle. In total the sum of those two angles must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So the missing angle must be also equal to 90 degrees in order to complete the sum of the angles on the other side of the N at point C to 180 degrees. This angle must be also equal to 90 degrees. So inside quadrilateral there are BMCN. We have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So in order to complete the sum of the angles in this quadrilateral to 360 degrees, this angle must be equal to 90 degrees. So we focus on the lower side of line segment AM at point B. This angle equals to 90 degrees, this angle equals to 90 degrees, so the sum of those two angles is 90 degrees plus 90 degrees, it is 180 degrees. That is to say, angle ABM equals to 180 degrees. Angle ABM is equal to 180 degrees. Therefore, angle ABM that is equal to 180 degrees is a straight line. Any angle that is equal to 180 degrees must be a straight line. Angle ABM is a straight line, so if angle ABM is a straight line, it means that line segment ABM is a straight line, and if line segment ABM is a straight line, line segment AM is also a straight line. Okay, line segment AM is also a straight line. If line segment AM is a straight line, it means that shape APM, this shape must be a right angle. Shape APM is a right angle, therefore we will implement the Pythagoras theorem on the right angle, triangle APM. We will implement the Pythagoras theorem on the right green triangle, triangle APM. by PT is abbreviation for Pythagoras theorem. In the right triangle APM, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle APM is AP. Therefore, the square of the hypotenuse is AP square. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM square plus AM square. Repeat again, in the right green triangle APM, AP square equals to PM square plus AM square. So here the hypotenuse AP equals to 5 units, therefore the square of the hypotenuse is 5 squared, that is 25. And it must be equal to PM square. PM equals to B according to our definition, therefore PM square is B squared plus AM square. Here we will define the side length of square ABCD as x, therefore all of its sides will be equal to x units in their lengths. So the length of side AM is A plus x. Okay? So AM equals to A plus x, therefore AM square will be equal to A plus x square. In conclusion, we found out that according to equation number 2, 25 equals to B square plus A plus x square. Here we open the brackets on this side of equation number 2 and we get that according to equation number 2, 25 equals to B square plus A plus x square equals to A square plus x square plus 2ax. So here we have B square plus A square in this equation number 2, but we have already found out that B square plus A square according to equation number 1 is equal to 9, therefore we can substitute A square plus B square plus A square in this equation number 2 by 9. We will do it now, we get that 25 equals to 9 plus x squared plus 2ax. Here we subtract 9 from this equation number 2, and we get that according to equation number 2, 25 minus 9 is 16, that is equal to x squared plus 2ax. Here we subtract x squared from this equation number 2, and we get that according to equation number 2, 16 minus x squared equals to 2ax. Here we divide this equation number 2 by 2x, and we get that according to equation number 2, a equals to 16 minus x squared over 2x. So actually found out the value of a in terms of x. We have already found out that quadrilateral BMCN has 4 right angles, therefore quadrilateral BMCN that has 4 right angles is a rectangle. I write it down, quadrilateral BMCN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. Bm equals to Cn. But according to our definition, Bm equals to A. So you can write here that Vm equals to A. And from this equation, A equals to Bm equals to Cn, we derive that Cn is also equals to A. Cn is equal to A. So you can write down here that Cn equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that BC equals to Mn. BC equals to Mn. But according to our definition, BC equals to X, so we can write down that BC equals to X. And from this equation, X equals to BC equals to Mn, we derive that Mn is also equals to X. Mn equals to X. In the next step, we will implement the Pythagoras theorem on the right big green triangle, triangle PCN. The right big triangle, triangle PCN, by P T is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle PCN is PC, therefore the square of the hypotenuse is PC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to Pn squared plus Cn squared. Repeat again, in the right green triangle, triangle PCN, according to the Pythagoras theorem, PC squared equals to Pn squared plus Cn squared. According to what is given us in the question, PC equals to 6, therefore PC squared is 6 squared, that is 36. That is equal to Pn squared. Pn equals to B plus X. Pn equals to B plus X. Therefore Pn squared is B plus X squared. Plus Cn squared. Cn equals to A, therefore Cn squared is A squared. So in conclusion, we found out that according to equation number 3, 36 equals to B plus X squared plus A squared. Here we'll open the brackets on this side of equation number 3, and we found out that according to equation number 3, 36 equals to B plus X squared equals to B squared plus X squared plus 2bx plus A squared. So here we have B squared plus A squared in this equation, equation number 3. And we know that B squared plus A squared according to equation number 1 equals to 9. Therefore we substitute B squared plus A squared in this equation, equation number 3 by 9. And we get that according to equation number 3, 36 equals to 9 plus X squared plus 2bx. Here we subtract X squared for this equation, equation number 3, and we get that according to equation number 3, 36 minus, here we subtract 9, first of all, from the equation number 3, and we get that here 36 minus 9 is 27, that is equal to X squared plus 2bx. Here we subtract x squared from this equation number 3, and we get that according to equation number 3, 27 minus x squared equals to 2bx. So here we divide this equation number 3 by 2x, and we get that according to equation number 3, b equals to 27 minus x squared over 2x. So we found the value of b in terms of x, and we have already found out the value of a also in terms of x. And here we have equation, according to equation number 1, we have already found out that a squared plus b squared equals to 9. We already found out that a equals to 16 minus x squared over 2x. So if we square this expression, we get the value of a squared, of course, plus b squared. b equals to 27 minus x squared over 2x. So if we square this expression, we get the value of b squared, of course, that is equal to 9. So here we'll open the brackets of those two expressions, and we get that 16 minus x squared is 16 squared, that is 256, plus x squared is x to the power of 4, minus 2 times 16 is minus 32 times x squared. And because of the fact that those two expressions have the same denominator, we can add the numerator of the first expression to the numerator of the second expression, and we get that 27 minus x squared equals to 27 squared, that is 729, plus x squared is x to the power of 4, minus 2 times 27 is minus 54 times x squared, all divided by 2x squared, that is 4x squared, that is equal to 9. So here $256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4, minus 32x squared minus 54x squared is minus 86x squared, all divided by 4x squared. It is equal to 9. Here we multiply this equation number 1 by 4x squared, and we get that according to equation number 1, two times x to the power of 4 minus 86x squared plus 985 equals to 9 times 4x squared is 36x squared. So here we subtract 36x squared from this equation number 1, and we will get that according to question number 1, two times x to the power of 4 minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. Here we define z as x squared, that is to say z equals to x squared according to our definition. So if z equals to x squared, it means that z squared will be equal to x to the power of 4. Therefore, 2 times x to the power of 4 will be equal to z squared minus 122 x squared. X squared is z, so we substitute x squared by z, so this expression will be equal to minus 122z plus 985 equals to 0. So 2z squared minus 122z plus 985 equals to 0 is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. And the variable that we are looking for is z, so x equals to z. So we put the data inside the formula for x, and we find out the value of the values of z because x equals to z. So we get here that z equals to minus b. b is minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared. b equals to minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times a. a is 2, so minus 4 times a is minus 4 times 2, that is minus 8, times c. c is 985, therefore minus 8 times 985 is 7,000, minus 7,880, all divided by 2a. a is 2, so 2a is 2 times 2, that is 4. In conclusion, we found out that z equals to 122 plus minus, and the square root of 14,884 minus 7,880 is 7,004. So inside the root we left only 7,004 over 4. So z equals to 122 plus minus, and the square root of 7,004 is 83.6899 divided by 4. So here we have two solutions that are possible for z. The first solution for z is z equals to 122 plus 83.6899 over 4. And 122 plus 83.6899 is 205.6899, and if we divide it by 4, we get that Z equals to 51.4224. So I actually found out that Z that is equal to x squared according to our definition, it is equal to 51.4224. So here we take out of this equation in order to find out the value of x itself. And the square root of 51.4224 is 7.17 units. So I found out that x equals to 7.17 units. Here AB that is equal to x, AB that is equal to x, it is equal to 7.17 units, but it is impossible that x equals to 7.17 units, and I'll explain you why. Because if we focus on the right triangle, triangle APM, the hypotenuse AP equals to 5 units. And the hypotenuse is the biggest side in any right triangle. So AP, the hypotenuse AP is the biggest side in the right triangle, triangle APM. That is to say, AP is bigger than AM. So AP is bigger than AM. So if AP is bigger than AM, let alone that AP is bigger than AB, that is part of AM. So here AP that is equal to 5 units is bigger than AB that is equal to x. So I write it down and found out that in the right triangle, triangle APM, the right green triangle, triangle APM, the hypotenuse AP that is equal to 5 units is bigger than AB that is equal to x. Okay, so we have this equality, 5 equals to AP, and it is bigger than AB that is equal to x. So from this inequality we will derive that x is less than 5 units. X is less than 5 units. It is very easy to see it from the inequality. X must be less than 5 units. But we just right now found out that x equals to 7.17, that is bigger than 5. So x must be less than 5 units, and found out that x is bigger than 5 units. So due to the contradiction, we cancel the possibility that z equals to 51.4224 units, and we'll focus on the second possibility for z. The second possibility for the value of z is that z equals to 122 minus 83.6899 divided by 4. So z equals to 122 minus 83.6899 is equal to 38.3101, and if we divide 38.3101 by 4, we will get that it is equal to 9.5775. So z that is equal to x squared, it is equal to 9.5775. We'll take a root out of this equation in order to find out the value of x. The square root of 9.5775 is 3.09 units, and indeed AB that is equal to x is equal to 3.09 units, that is less than the hypotenuse that is equal to 5 units. Therefore we don't have any contradictions here, and therefore the answer to the question will be, what is the area of square ABCD? The area of this square ABCD is equal to x squared. Again, the area of square ABCD is equal to x squared, but according to our definition, x squared equals to z, and we just found out that z equals to 9.5775. That is to say, the area of square ABCD equals to 9.5775 square units. Okay, and that is the answer to the question. The area of square ABCD equals to 9.5775 square units. We finished with the first question. In the next step, I will present to you the second question. The area of this square ABCD equals to 9.5775 square units. So in the next step, I present to you the second question. In the drawing, we have a right triangle ABC, angle ABC equals to 90 degrees. Inside triangle ABC, we have a circle, and inside the circle, we have angle triangle DOE, and we are looking for this angle theta, that is inside triangle DOE. Okay, it is given us the question that a line segment AD equals to line segment EC, and line segment DE is twice as long as AD, and it is also twice as long as CC. Our mission is to find out the size of this angle theta. So first of all, we define line segment DE as 2A. Here, line segment DE equals to 2A according to our definition. And according to what is given as the question, we know that AD equals to CE, and it is equal to DE over 2. But according to our definition, DE equals to 2A, so we substitute DE by 2A. 2A over 2, 2A over 2 is A. So from this long equation, AD equals to C equals to D over 2 equals to 2A over 2 equals to A, we will derive that AD equals to CE, that is equal to A. That is to say, AD equals to A, and EC is also equals to A. In the next step, I present to you rule number 4, and we will implement rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. Point O is the center of the circle. We have perpendicular OM that, according to rule number 4, bisects chord CD. That is to say, CM equals to MD, and each part is half of CD. That is to say, CM equals to CD over 2 and MD is also equals to CD over 2. We can implement rule number 4 in our drawing. Here from the center of this circle, that is to say from point O, we'll go perpendicular on chord DE. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord DE is T. So here, according to rule number 4, dt equals to TE. I write in that according to rule number 4, dE equals to TE, and dt equals to d over 2, and TE is also equals to d over 2. dE over 2. Again, dt equals to TE, dt equals to d over 2, and TE also equals to dE over 2. But according to our definition, d equals to 2a, and 2a over 2 is a. So from this long equation, dt equals to t equals to d over 2 equals to 2a over 2 equals to a, we will derive that dt equals to te equals to a. That is to say, dt equals to a, and te is also equals to a. Okay? In the next step, we define the point of tendency of tangent AB with this circle as point M. We define the point of tendency of tangent BC with this circle as point N. We join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle that we define as R. OM equals to R. And we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency, we get that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we join points O and N together by a straight line. Point O is the center of the circle. Point N is the point of the circle itself. Therefore, ON is the radius of the circle that is equal to R. And again, we have the radius ON that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So inside quadrilateral MOBN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. So, in quadrilateral MOBN, we have 4 right angles. Therefore, quadrilateral MOBN is a rectangle. I'll write it down. Quadrilateral MOBN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN. But we have already found out that MO equals to R. So, from this equation, R equals to MO equals to BN, we derive that BN is also equals to R. BN equals to R. Bn equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we'll get that ON equals to MB. ON equals to MB. But we have already found out that ON equals to R. It is the radius of the circle. And from this equation, R equals to ON equals to MB, we derive that MB is also equals to R. MB equals to R. And right here that MB equals to R. So we actually found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to each other. So we write it down, quadrilateral MOBN is a square. In the next step, I'll present to you rule number 10, and we'll implement rule number 10 in our drawing. We have the external point P. From the external point P, we have tangent PA, and we have from point P the straight line that intersects with this circle at points P and C. So if this is the data that has been given to us, then the following equation is true, that AP square equals to PB times PC. Again, AP square equals to PB times PC. Actually, you can implement rule number 10 in our drawing. Why? Because in our drawing, if we focus on the external point C, in the external point C, we have tangent CN, and we have the straight line that intersects with this circle at points E and D. Therefore, according to rule number 10, we get that Cn square equals to Ce times Cd. Repeat again, Cn square, according to rule number 10, Cn square equals to Ce times Cd. Okay. So Cn square equals to Ce. C equals to A, therefore we substitute C by A times CD. What is the value of CD? It is very easy to see from the drawing that CD equals to A plus A plus A, that is 3A, therefore we substitute CD by 3A. And we get that Cn square equals to A times 3A, that is 3A square. Here you take out of this equation and you get that Cn equals to the square root of 3 square is the square root of 3 square is 8, the square root of 3 is the square root of 3, so in conclusion we found out that Cn square equals to the square root of 3, the square root of Cn square that is equal to the square root of 3a squared is equals to the square root of 3 times a. Here Cn equals to the square root of 3 times a. Likewise, we'll focus on the external point A. From the external point A, we have tangent AM to the circle, and also from point A, we have the straight line that intersects with this circle at points D and E. Therefore, according to rule number 10, we get that AM squared equals to AD times AE. Again, AM squared equals to AD times AE. Write it down, AM squared equals to AD times AE. Repeat again. AM squared equals to AD times AE. So AM squared equals to AD equals to A, so substitute AD by A times AE. What is the value of AE? A equals to A plus A plus A, that is 3A. Therefore, we substitute AE by 3A. So in conclusion, we found out that AM squared equals to A times 3A, that is 3A squared. We take out of this equation and we get that AM is also equals to the square root of 3 times A. AM equals to the square root of 3 times A. So now I get that AM equals to the square root of 3 times A. The next step, I will copy the right triangle ABC in a new page and we will analyze triangle ABC. The right triangle ABC. What is the length AB of the right triangle ABC? It is very easy to see from the drawing that AB equals to square root of 3 times A plus R. Likewise, the length of line segment BC, it is also equal to the square root of 3 times A plus R. And what is the length of the hypotenuse AC? The length of the hypotenuse AC equals to A plus A plus A plus A, that is 4A. So this is actually the right triangle ABC that they copied from the original drawing. Side AB and side BC, they are both equal to square root of 3 times A plus R, therefore they are equal to each other. Okay, side AB equals to side BC, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if we define this angle as alpha, then this angle must be also equal to alpha because of the fact that those two angles are equal to each other. This angle equals to 90 degrees, therefore the other two angles must be also equal to 90 degrees. Because 90 degrees plus 90 degrees, it is 180 degrees, that is the sum of the angles in any triangle. So here alpha plus alpha must be equal to 90 degrees. Alpha plus alpha equals to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. We divide this equation by 2, and we get that alpha equals to 45 degrees. Angle alpha equals to 45 degrees. And I tell that angle alpha equals to 45 degrees, and here also angle alpha equals to 45 degrees. We continue to focus on the right triangle, triangle ABC. If we focus on this angle, we get that cosine 45 degrees is equal to BC over AC. Is equal to BC over AC. So cosine 45 degrees equals to BC. BC is equal to 3 times A plus R over AC. AC is 4A, so we substitute AC by 4A. And cosine 45 degrees is 1 over square root of 2. That is equal to square root of 3 times A plus R over 4A. Here we multiply this equation by 4a, and we get that 4a over square root of 2 is equal to square root of 3 times a plus r. Here we substitute 4 by 2 times 2, and we get that 2 times a over square root of 2. It is equal to square root of 3 times a plus r. So here we substitute one of the 2's by square root of 2 times square root of 2, and we get that square root of 2 times square root of 2 over square root of 2 times 2a equals to square root of 3 times a plus r. So here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and we're left only with 2 times square root of 2 times a equals to square root of 3 times a plus r. Here we subtract square root of 2 times a from this equation, and we get that 2 times square root of 2 times a minus square root of 3 times a equals to r. So here we take a as a common factor out of those two expressions. So a is a common factor. What is left from 2 times square root of 2 times a after we took from it a as a common factor? What is left? It is actually 2 times square root of 2. And what is left from minus square root of 3 times a after we took from it a as a common factor? What is left? It is actually minus square root of 3. Is equal to r. So in conclusion, we found out that the radius of the circle r, it is equal to a times 2 times square root of 2 minus square root of 3. Here, point O is the center of the circle, point D is the point of the circle itself, therefore D is the radius of the circle, that is equal to R. In the next step, I will copy the right green triangle DOT in a new page, and we analyze triangle DOT. So actually this is the right triangle DOT, that is the coordinate of the original drawing. It is very easy to see from the drawing that cosine theta equals to dt over OD. Again, cosine theta equals to dt over OD. Cosine theta equals to dt over OD. Okay, so dt equals to A and OD equals to R. So cosine theta equals to A over R. And we have already found out that R equals to A times 2 times square root of 2 minus square root of 3. So in conclusion, we found out that cosine theta equals to A over A times 2 times square root of 2 minus square root of 3. So here we have A in the numerator and A in the denominator, so A will get cancelled and we left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. Okay. Our mission is to find out the value of theta itself. In order to find out the value of theta itself, we will operate the opposite function of cosine, that is cosine minus 1, on the result, that is 1 over 2 times square root of 2 minus square root of 3, and this way we get the value of theta itself. So the opposite function of cosine is cosine minus 1. We will operate it on the result, that is 1 over 2 times square root of 2 minus square root of 3, and when we operate the opposite function of cosine, that is cosine minus 1, the result, that is 1 over 2 times square root of 2 minus square root of 3, we get the value of theta itself. And when we operate the opposite function of cosine, that is cosine minus 1, on this number, that is 1 over 2 times square root of 2 minus square root of 3, we will get that this expression equals to 24.203 degrees. And this is equal to theta, of course. So we found out that angle theta equals to 24.203 degrees. So I write it down here that we found out that this angle theta equals to 24.203 degrees. We finish the second question. In the next step I will summarize the lecture. We'll start with the first question, of course. In the drawing we have square ABCD. We know that line segment AP equals to 5 units, line segment BP equals to 3 units, line segment BC equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all, we did the construction. We extended side DC of the square by straight line, and from point P we draw perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P in the extended DC as n. Then we did another construction from point B. We drew perpendicular on Pn. Again, from point B, we draw perpendicular on Pn. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and Pn as M. Then we define side PM as B, we define side BM as A, and we implemented the Pythagoras theorem on the right green triangle, triangle PBM. According to the Pythagoras theorem, PB square equals to PM square plus BM square. In the right triangle, triangle PBM, according to the Pythagoras theorem, PB square equals to PM square plus BM square. PB equals to 3, therefore PB square is 3 squared, that is 9, and it is equal to PM square. PM is B, therefore PM square is B square plus BM square. BM is A, so BM square is A square. So in conclusion, found out that according to equation number 1, 9 equals to B square plus A square. Here, DC is one side of square ABCD, therefore it is absolutely a straight line. And when we extended the straight line DC by straight line, the result is DN. When you extend the straight line by straight line, the result must be a straight line, therefore DN must be a straight line. So DN is a straight line. So if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees, according to rule number 3, that the sum of the angles on the upper side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DE, of DN at point C? We have this angle that is equal to 90 degrees, therefore plus the missing angle, in total they must be equal to 180 degrees. The missing angle must be equal to 90 degrees in order to complete the sum of the angles in the upper side of DN at point C to 180 degrees. This angle must be equal to 90 degrees. So inside quadrilateral BNCN we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle, the missing angle, must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here, in order to complete the sum of the angles in this quadrilateral to 360 degrees, this angle must be equal to 90 degrees. So inside quadrilateral BNCN, we have 4 right angles. Then, we focus on the lower side of line segment AM at point B. This angle equals 90 degrees, this angle equals 90 degrees, 90 degrees plus 90 degrees is 180 degrees. So angle ABM equals to 180 degrees, therefore angle ABM is a straight line. If angle ABM is a straight line, then line segment ABM is a straight line, and if line segment ABM is a straight line, it means that line segment AM is also a straight line. So if line segment AM is a straight line, it means that shape APM, this shape is a right triangle. Therefore, we implemented the Pythagoras theorem on the right green triangle, triangle APM. According to the Pythagoras theorem, AP square equals to PM square plus AM square. In the right triangle, triangle APM, AP square equals to PM square plus AM square. AP equals to 5, therefore AP square is 5 square, that is 25. PM equals to B, therefore PM square is B square. And what is the value of AM? AM equals to X plus A, therefore AM square is X plus A square. So in conclusion, found out that according to equation number 2, AP square equals to PM square plus AM square. 25 equals to B square plus A plus X square. Here we open the brackets on this side of equation number 2 and found out that according to equation number 2, 25 equals to B square plus A plus X square. A plus X square equals to A square plus X square plus 2AX. Here we have b squared plus a squared, but according to equation number 1, we found out that b squared plus a squared equals to 9. Therefore, we can substitute a squared plus b squared in this equation number 2 by 9. We did it when we got that 25 equals to 9 plus x squared plus 2ax. Here we subtracted 9 from this equation number 2, and found out that 25 minus 9 is 16, that is equal to x squared plus 2ax. Here we subtracted x squared from this equation number 2, and found out that 16 equals to x squared, 16 minus x squared equals to 2x. Here we divided this equation number 2 by 2x, and found out that a equals to 16 minus x squared over 2x. So we have the value of a in terms of x. We have already found out that in quadrilateral BMCN we have 4 right angles. Therefore, quadrilateral BMCN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. BM equals to CN, but according to our definition, BM equals to A. And from this equation, A equals to BM equals to CN, we will derive that CN is also equals to A. Here, CN equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that BC equals to MN. But BC equals to X according to our definition. And from this equation, X equals to BC equals to MN, we will derive that MN is also equals to X. Then we implemented the Pythagoras theorem on the right green triangle, triangle PCN. According to the Pythagoras theorem, PC squared equals to PN squared plus CN squared. In the right green triangle, triangle PCN, PC squared equals to PN squared plus CN squared. PC equals to 6 according to what is given as the equation, therefore PC squared is 6 squared, that is 36. And it is equal to Pn squared. Pn equals to b plus x, therefore Pn squared is b plus x squared plus Cn squared. Cn equals to a, therefore Cn squared is a squared. So in conclusion, found out that according to equation number 3, 36 equals to b plus x squared plus a squared. We open the brackets on this side of equation number 3 and found out that according to equation number 3, 36 equals to b plus x squared is b squared plus x squared plus 2bx plus a squared. So again, here we have b squared plus a squared, and according to equation number 1, b squared plus a squared equals to 9. Therefore, we substitute b squared plus b squared in this equation number 3 by 9, and we got that 36 equals to 9 plus x squared plus 2bx. Here we subtracted 9 from this equation number 3, and we found out that according to equation number 3, 36 minus 9 is 27, that is equal to x squared plus 2bx. Here we subtracted x squared from this equation number 3, and found out that according to equation number 3, 26 minus x squared equals to 2bx. Here we divided this equation number 3 by 2x, and found out that according to equation number 3, b equals to 27 minus x squared over 2x. So we have the values of a and b in terms of x, and here, according to equation number 1, we know that a squared plus b squared equals to 9. A is 16 minus x squared over 2x. If we square this expression, we get the value of a squared, of course. B is 27 minus x squared over 2x. So if we square this expression, we get, of course, the value of b squared, and it is equal to 9. Then we open the brackets of those two expressions. Here we have 16 minus x squared squared is 16 squared, that is 256, plus x squared squared is x to the power of 4, minus 2 times 16 is minus 32 times x squared. And because of the fact that those two expressions have the same denominator, we can add the numerator of this expression to the numerator of this expression. Okay, and therefore we got here that 27 minus x squared squared is 27 squared, that is 729, plus x squared squared is x to the power of 4, minus 2 times 27 is minus 54 x squared. All divided by 2x squared. 2x squared is 4x squared, that is equal to 9. Here 256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. And minus 32x squared minus 54x squared is minus 86x squared. divided by 4x squared equals to 9. Here we multiply this equation of 1 by 4x squared, and we got that 2 times x to the power of 4 minus 86x squared equals plus 985 equals to 9 times 4x squared is 36x squared. Here we subtracted 36x squared from this equation number 1, and found out that 2 times x to the power of 4 minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. Then we define z as x squared. If z equals to x squared, it means that z squared equals to x to the power of 4. Therefore, 2 times x to the power of 4 will be equal to 2 times z squared minus 122 x squared is z, so we substitute x squared by z, and we got here minus 122z plus 985 equals to 0. 2z squared minus 122z plus 985 that is equal to 0. It is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of a quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. And the variable that we are looking for is z, so x equals to z. So we put the data inside the equation for x and found out the value of the values of z, because z equals to x. So here we found out that z equals to minus b. B is minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884. Minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is 985, so minus 8 times 985 is minus 7,880, all divided by 2a. A is 2, so 2 times a is 2 times 2, that is 4. So we found out that z equals to 122 plus minus 14,884 minus 7,880 is 7,004. So inside the root we left only with 7,004 divided by 4. So we found out that z equals to 122 plus minus 83.6899 over 4. So z equals to 100. Here we will have two solutions that are possible for z. The first solution for z is z equals to 122 plus 83.6899 over 4. 122 plus 83.6899 is 205.6899, and if we divide it by 4, we'll get that z equals to 51.4224. So we actually found out that z that is equal to x squared, according to our definition, it is equal to 51.4224. So we took a root out of this equation in order to find out the value of x, and the square root of 51.4224 is 7.17 units. So we found out that x equals to 7.17 units. So here a b that is equal to x, it is equal to 7.17 units, but it is impossible that x equals to 7.17 units, and I'm explaining why. Because in the right triangle APM, the hypotenuse AP equals to 5 units, and we know that the hypotenuse is the biggest side in any right triangle, therefore AP is the biggest side in this triangle APM. That is to say, AP is bigger than AM. AP is bigger than AM, so if AP is bigger than AM, let alone that AP will be bigger than AB that is part of AM. So we found out that the hypotenuse AP that is equal to 5 is bigger than AB that is equal to x. So we can write here that in the right triangle APM, the hypotenuse AP that is equal to 5 is bigger than AB that is equal to x. So from this inequality, we will derive that x is less than 5 units. So according to the drawing, x must be less than 5 units. But we just right now found out that x equals to 7.17 units, that is bigger than 5 units. Okay, so we have a contradiction here. That is to say, x cannot be 7.17 units because x must be less than 5 units, and 7.17 units is bigger than 5 units. Therefore, we cancel this solution. Z cannot be equal to 51.4224 units. And we'll focus on the second solution for Z, is that Z equals to 122 minus 83.6899 over 4. 122 minus 83.6899 is 38.4101, and if we divide it by 4, we get that Z equals to 9.5775. So Z, that is equal to x squared according to our definition, it is equal to 9.5775. Here we take out of this equation in order to find the value of x itself. The square root of 9.5775 is 3.09. So we found out that x that is equal to AB, it is equal to 3.09. That is smaller than the hypotenuse AP, that is equal to 5 units. So we don't have here any contradictions. And what is the area of square ABCD? The area of square ABCD equals to x squared. So the area of square ABCD that is equal to x squared, that is equal to Z, we just right now found out that is equal to 9.5775. That is to say, the area of square ABCD equals to 9.5775 square units, and that is the answer to the question. We finish with the first question, then I presented to you the second question. So in the drawing, we have a right triangle ABC, angle ABC equals to 90 degrees. Inside triangle ABC we have a circle. Inside the circle we have triangle DOE. We are looking for this angle theta that is inside triangle DOE. According to what is given as the question, line segment AD equals to line segment EC, and line segment DE is twice as long as AD, and it is also twice as long as CC. Our mission is to find out the size of this angle theta. It is given as the question that AD equals to CE equals to DE over 2. So we define DE as 2A, D equals to 2A according to our definition. So from what is given as the question, we get that AD equals to CE equals to DE over 2. And according to our definition, D equals to 2A, so we can substitute DE by 2A. Here we get that 2A over 2 is equals to A. From this long equation, we derive that AD equals to CE equals to A. So AD equals to A, and EC is also equals to A. Then I presented to you rule number 4, and we implemented rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of the circle to a chord bisect the chord. The center of the circle is point O. We have the perpendicular OM, that according to rule number 4, this rule, the perpendicular OM bisects chord CD. That is to say, CM equals to MD, and CM equals to CD over 2, and MD is also equals to CD over 2. Okay, we can implement rule number 4 in our drawing. From the center of the circle that is point O, we draw perpendicular on chord DE. This angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and DE is T. According to rule number 4, DT equals to TE. dt equals to te, and dt is equal to d over 2, and te is also equals to d over 2 because of the fact that chord DE has been bisected into two halves. Each half equals to d over 2. So in conclusion, we found out that dt equals to te equals to d over 2, and according to our definition, d equals to 2a. So we can substitute d by 2a, and we get that 2a over 2 is a. So from this long equation, we got that dt equals to te equals to a. dt equals to te equals to a. That is to say, dt equals to a, and te is also equals to a. Then we define the point of tendency of tangent AB with this circle SM. We define the point of tendency of tangent BC with this circle SM. We join points O and M together by O and M together by straight line. Point O is the center of the circle. Point M is the point of the circle itself. Again, point O is the center of the circle. Point M is the point on the circle itself. This is exactly the definition of a radius. That is to say, OM is the radius of this circle that is equal to R according to our definition. So OM equals to R. And we have the radius OM that is drawn to the point of tendency. Therefore, this angle will be equal to 90 degrees, and this angle must be also equal to 90 degrees according to rule number 1. Likewise, we join points O and N together by straight line. Point O is the center of the circle. Point N is the point of the circle itself. Therefore, ON is the radius of the circle that is equal to R. We have the radius ON that is drawn to the point of tendency. Therefore, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Inside quadrilateral BNMO, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. So inside quadrilateral MOBN, we have 4 right angles. Therefore, quadrilateral MOBN is a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. But MO equals to R according to what we have already found out. And for this equation, R equals to MO equals to BN, we will derive that BN is also equals to R. Here BN is also equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that ON equals to MB. But ON equals to R according to what we have already found out. So for this equation, R equals to ON equals to MB, we will derive that MB is also equals to R. Here MB is also equals to R. So we actually found out that quadrilateral MOBN is not a rectangle, but a square because all of its sides are equal to each other, they are equal to R. Okay, then I presented to you rule number 10, we implemented rule number 10 in our drawing. According to rule number 10, if we have the external point P, from point P we have tangent PA to the circle, and from point P we have this straight line that intersects with the circle at points B and C. So if this is the data that has been given to us, then the following equation is true, that AP square equals to PB times PC. Again, AP square equals to PB times PC. Okay, we can implement rule number 10 in our drawing, because in our drawing, if we focus on the external point C, we have tangent CN, and we have this from point C, the straight line that intersects with this circle at point C and D. Therefore, according to rule number 10, we get that Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. Okay, again, according to rule number 10, if we focus on the external point C, Cn square equals to Ce times Cd. So Cn square equals to Ce. Ce is A times Cd. Cd is A plus A plus A, that is 3A, so we substitute CD by 3A. And in total, we found out that Cn square equals to A times 3A. Cn square equals to A times 3A is 3A square. We took out of this equation and found out that Cn equals to square root of 3 times A. Likewise, we focused on the external point A. From the external point A, we have tangent AM to the circle, and we have from point A the straight line that intersects with this circle at points D and E. Therefore, according to rule number 10, AM square equals to AD times AE. Again, AM square equals to AD times AE. Repeat again. And the example point A, according to rule number 10, AM square equals to AD times AE. AD equals to A equals to A plus A plus A, that is 3A, therefore we substitute AE by 3A. And in conclusion, we found out that AM squared equals to A times 3A. That is to say, AM squared equals to A times 3A is 3A squared. Took out of this equation, we found out that AM equals to square root of 3 times A. AM equals to square root of 3 times A. Then I copied the right triangle, triangle ABC in a new page, and we analyze triangle ABC. This is the right triangle, triangle ABC that I copied from the original drawing. Side AB equals to square root of 3 times A plus R, and side AC is also equals to square root of 3 times A plus R. And the hypotenuse AC equals to A plus A plus A plus A, that is 4A. So this is the right triangle, triangle ABC that I copied from the original drawing. So side AB and side BC, they are both equal to square root of 3 times A plus R, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if one angle is alpha, then the other angle must be also equal to alpha. This angle equals 90 degrees, so the other two angles must be also equal to 90 degrees, because 90 degrees plus 90 degrees is 180 degrees, and this is the sum of the angles in any triangle. That is to say, alpha plus alpha must be equal to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. We divided this equation by 2 and found out that alpha equals to 90 degrees over 2, that is 45 degrees. So each angle here that is equal to alpha, it is equal to 45 degrees. Then we focus on this angle. This angle is 45 degrees. So here cosine 45 degrees. This right triangle will be equal to BC over AC. Again, cosine 45 degrees equals to BC over AC. Okay. Cosine 45 degrees equals to BC over AC. BC is square root of 3 times A plus R, and AC is 4A. Cosine 45 degrees is 1 over square root of 2, so in conclusion we found out that 1 over square root of 2 equals to square root of 3 times A plus R over 4A. We multiplied this equation by 4A. We found out that 4A over square root of 2 is equal to square root of 3 times A plus R. Then we substituted 4 by 2 times 2 and found out that 2 times 2 times A over square root of 2 equals to square root of 3 times A plus R. Here we substituted one of the 2's by square root of 2 times square root of 2, and we got that square root of 2 times square root of 2 times 2A over square root of 2 equals to square root of 3 times A plus R. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled. And we left only with 2 times square root of 2 times A, that is equal to square root of 2 times A plus R. Here we subtracted square root of 2 times A from this equation, and we found out that 2 times square root of 2 minus square root of 3 times A equals to R. Here we took A as a common factor out of those two expressions. So A is a common factor. What is left from 2 times square root of 2 times A after we took point A as a common factor? What is left? It is actually 2 times square root of 2. And what is left from minus square root of 2 times A after we took point A as a common factor? What is left? It is actually minus square root of 3. So in conclusion, we found out that the radius of the circle equals to A times 2 times square root of 2 minus square root of 3. So here point O is the center of the circle, point D is the point of the circle itself. This is exactly the definition of a radius. That is to say, OD is the radius of the circle, that is equal to R. Then I copied the right triangle, triangle DOT in a new page, and we analyzed triangle DOT. This is the right triangle, triangle DOT that I copied from the original drawing. In this triangle DOT, it is very easy to see that cosine theta equals to dt over dO. Again, cosine theta equals to dt over dO. Cosine theta equals to dt over dO. dt equals to A, dO equals to R. So cosine theta equals to A over R, and R equals to R times A times 2 times square root of 2 minus square root of 3. Therefore we substitute R by A times 2 times square root of 2 minus square root of 3. Okay, so in conclusion, we found out that cosine theta equals to A over a times 2 times square root of 2 minus square root of 3. We have a in the numerator and a in the denominator, so a will get cancelled and we're left only with cosine theta, that is equal to 1 over 2 times square root of 2 minus square root of 3. Our mission is to find out the value of theta itself. In order to find out the value of theta itself, we will operate the opposite function of cosine, that is cosine minus 1, on the result, this expression, in order to find out the value of theta itself. So we operated the opposite function of cosine, that is cosine minus 1, on the result, that is 1 over 2 times square root of 2 minus square root of 3. In this way, you got the value of theta itself. Okay? So if you operate the opposite function of cosine, that is cosine minus 1, on 1 over 2 times square root of 2 minus square root of 3, you will get that this expression is equal to 24.203 degrees. That is to say, angle theta equals to 24.203 degrees. In conclusion, we found out that the size of this angle theta, it is equal to 24.203 degrees. Okay? Thank you very much.